Advanced Stair Construction, Lab 3, Circular Stairs. The first thing we'll do is lay out for the angle of our circular stairs. In this case, we're going to cover a 45-degree angle within the span of 6 treads. Each tread will have a width of 7.5 degrees. When we add 6 treads together, we'll get a total of 45 degrees of angular coverage of stair. We're ready to start our circular stair lab. The first thing we're going to do is we're going to establish our pivot point, or our center of the radius of our stair. I've got a mock-up of a couple sheets of cardboard here that I'll do my layout on. If cardboard is not available, you can lay it out anywhere on the floor. Just pick a convenient point for your pivot point that has at least 8 feet in 2 directions, 8 feet this way and 8 feet that way, so that you can do your proper layout procedures. I'm going to start by setting my pivot point at exactly 1 inch in from the edge of from the corner of my board. So 1 inch on either dimension or either side, which puts my center pivot point right there. Having that at exactly 1 inch just allows me to pull from this edge of my cardboard as a reference line when I'm laying out my various measurements. The next step is to establish what we're going to call our zero line. Okay, that's our reference line. That zero line will be the face of the first subriser. And I'm simply just going to parallel relative to the edge of my cardboard here. So I will, on the opposite end, just measure over 1 inch, make a mark, and snap my line through. So I'll take my chalk box, hook it onto my nail, and pull it nice and tight right through my point, and snap a nice clean line. So that is my zero line. That's where everything is going to be based from. Now we can do some layout, and the next line that we're going to snap will be our 45-degree line. So let's talk about how we're going to determine that position, or that exact angle. The first thing I'm going to do is find on my layout my 90-degree outside radius. What that means is, hooking my pivot point or my nail, I'm going to measure and make a mark at 90 inches. That'll be the outside of my tread, the radius of my tread. So I'll hook my tape. And when you're hooking your tape, so notice on the end of your tape there's a slot on the hook. That slot is so that you can fit the head of a nail in there to help hold and position that tape. So it pivots nice and freely and stays in place. I'll measure over 90 inches and make a mark right there. So now I have down here a mark at 90. This will be the outside radius of my treads. I want to find a single point down there that is 90 inches from this point, and we'll calculate the diagonal distance from our nail to the end over there to determine what that distance should be, and then we'll simply swing a couple of short arc lengths to triangulate that far corner. So let's first calculate that theoretical distance from our pivot point to the far end of our 90-inch by 90-inch right triangle. So let's go to our calculator to do that math. So to calculate the diagonal distance of a 90-inch by 90-inch right triangle, here's what we'll do. We'll type in 90-inch rise, 90-inch run, and ask it what the diagonal is. We get a distance of 127¼ inches. So that's the diagonal, or the hypotenuse, of our 90-inch by 90-inch right triangle. Hook my tape. And I don't know exactly where this point is going to be. I know approximately where it's going to be based on my mark over there. So I'm going to mark about a 6-inch cross, okay, using my pen, 127¼ So my tape, I'm going to hook my pen or my pencil at the 127¼ I'm just going to hold my pencil tight to my tape, and then use my tape measure as my compass, as my big compass or radius, and simply mark that distance as a long mark there. Now I can take, and if you remember, I offset my 0 line by 1 inch, so if I just add 1 inch to my 90 inches, I can hook the end of my plywood and find where my 91-inch mark lines up or crosses that arc that I made for my diagonal. So in this case, my mark is right there. So that crossing point is where those two meet, where the distance from that edge and the distance from my pivot point are per the design, or per what my calculations indicate. Now I'll take my chalk line and I'll snap from my pivot point through that point there. That'll be my 45-degree line. And I can also snap my chalk line through my 90 mark through that point as well to get a perfect 90-inch by 90-inch right triangle. Through my point, and lightly snap my line. And again, through my 90 mark, through my point, to there. So now I have 90, 90, and 127¼ which is the diagonal of a right triangle. This corner should be exactly 90 degrees. At this point, we're ready to start laying out and calculating the arc length and our divider lines for each individual tread. The design calls for a 7.5-degree increment from one tread to the next. So starting from my 0 line, I'll pivot over 7.5 degrees and snap a line. Pivot over another 7.5, okay, or 15 degrees from 0, and snap another line. And I'll keep doing that until I get to my 45-degree line. It'll total 6 individual treads or 5 intermediate lines. So how do we know where to snap each line? The first thing we need to do is we'll draw an arc through our 90-inch, and then we have to find what the length of that arc is. And we'll use our calculator to do that. Once we know the length of that arc, okay, the length along the curve, we'll take that distance, and we know we have 6 treads that need to cover that distance. So we'll take that arc length, we'll divide by 6 to get the arc length of each individual tread. And once we get down to an individual tread, the arc length, or the length along the curve, is very close to the chord length, which is the straight distance from the edge to each edge of a single tread. It's within a 1/16 of an inch. Okay, so that will help us lay out along the curve the position of each line. So I'm going to start by marking with my tape measure and my pen that curve of the outside arc. Make sure your space is clear because you're going to have to swing your tape the distance 45 degrees. And we can start at this end, but I'm actually more comfortable starting at the far end and walking backwards. So I'm simply going to leave my tape hooked, start here. I'm going to hold my pen or my pencil kind of in tandem with my tape measure so that the tip of my pencil is at my 90-degree mark. And I'm simply going to swing that dimension. Back along there. So again, I'm just using my tape as a giant compass, similar to how I did when I marked my point over there. So I now have my outside radius of my track. So let's calculate what that distance is. If we had a flexible tape, we could measure it, but the most accurate way is to calculate it with our Construction Master. So let's talk about how we do that. Our Construction Master Pro can calculate the arc length of a circle. You need to have the Pro. Okay, you cannot do this with a Construction Master 5 or Construction Master 4 or a Measure Master or a standard calculator. It needs to be the Pro version. You'll notice above some of the keys you have yellow words. Those yellow words correspond to the Convert button. That's just a secondary function of the calculator for individual buttons. The buttons we're going to be using are radius, okay, which is convert diag. So above the diagonal it says radius. So we're going to enter in the radius of our circle. In this case it's 90 inches. And we're also going to be using the arc button, which is on this particular calculator, it's from what says circle or circ. Okay, so we'll use the convert circ to find the arc of the arc length of our radius. So we want to know the distance along the curve of our 45-degree, 90-inch radius circle. So here's what we'll do. Type in our radius, 90 inches, hit the convert diag. Okay, that just tells it radius. So you'll see rad for radius, 90 inches. Now we want to tell it what the angle is. So we're going to type in 45 convert arc or circle. So now it says arc 45.00 degrees. Now if we hit the circle button again, it will give us the arc length, in this case 70 and 11/16. So we'll write down 70 and 11/16 on a notepad so that I can refer to that dimension again. If we were to take a flexible tape measure and start it here and measure along this radius all the way, this distance would measure 70 and 11/16. What we want to do is take that distance and divide by 6 so that we can find the position or the crossing point for the line of each tread. So we'll take 70 and 11 and divide by 6. I'm just going to clear the calculator. 70-inch 11/16 and divide by 6 equals 11 and 13/16. That will be one arc length of each individual tread. So that's another number to take a note of, 11 and 13/16. To confirm the chord length relative to the arc length, there will be a slight difference. It could be up to a 1/16 of an inch. We'll check it. So again, we'll type in our radius, 90-inch convert diagonal. That's our 90-inch radius. We type in 7.5 convert circle. okay, 7.5 degree arc, and hit the circle button again. We'll get our arc length of 11 3/4 in this case. So we're about a 1/16 off already. If we hit the arc button again, we'll actually get the chord length. The chord says it's the same, 11 3/4. Now obviously this calculator is rounding up to the nearest, up or down to the nearest 1/16 of an inch. But for our layout purposes, we're not going to be able to be more accurate than a 1/16 of an inch anyway. Our chord length and our arc length are about the same in this case at 11 3/4. So that is how we're going to divide up each individual tread. We'll start at our 0 mark, we'll measure over 11 3/4, make a mark, and then just step off 11 3/4. So I've divided my arc length into 6 equal parts, and each tread will need to be with an arc length and a chord length of 11 3/4 inches. So I'll take my tape and I'll start at 0. Just hold my tape right at my intersection of my arc and my 0 line. Find 11 3/4. Make a mark. A circle line. And step that off each time. 11 3/4. And 3/4, 11 3/4, and the last one should be pretty close to 11 3/4, maybe just a hair big. You may get off fractionally over the 6 measurements. Hopefully you're within 1/8 of an inch or so to your point there. So I have crossing line here, 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 and here. So I'll take my chalk line and I'll snap those lines through for each tread. I'm going to snap them through a little bit extra long because I still have a wall that's going to go in here, and I'll need that layout to transfer to my wall as well. So I'll come out about 6 inches beyond my 90 degree arc line. Through my point, snap. Snap, snap, so I have 6 equal treads that are all 7.5 degrees. I'm going to swing a couple more arc lines to represent the inside and the outside of my curved stringer, and then also an arc line that's offset by 3.5 inches on the outside for my curved die wall that I'll build to anchor my outside radius of my stairs to. If you refer to your plans on page 2, we have a 60-inch inside radius and then another 1.5 inches beyond that for our stringer. So we'll mark a 60-inch and a 61.5-inch radius. So again, I'll start from my 45 line, hold my tape at my 60-inch, hold my tape in my pen, and swing my arc at 60, and again at 61.5. Okay, that will be my stringer. And then again at 93.5 for the outside of my die wall. So there we have our layout on our floor. We have our die wall, we have our stringer, and we have the shape of each tread. This pie shape, or wedge shape that we see here will be exactly what we cut our treads to. We'll have to transfer these marks to a sheet of plywood. We'll make one as a template, and each of these, in theory, will be exactly the same. I should be able to interchange any one of these treads with the other, and they should all be exactly identical. When we stack them together, they should nest right on the floor and fit to fill the space that we've laid out.